and exponents. So because this whole chapter that we're starting is going to be on operations involving some different patterns that go with when you're using operations with exponents. So a lot of new stuff after today. So today it's just reviewing what an exponent is and a couple of the things that can sneak up on you. So your objective is to use an exponent with any number. So we're going to focus on some fractions and negative numbers and things like that. And then your other objective is to be able to substitute negative numbers. So just reviewing our vocabulary, you have the whole thing here in the box is a power. And then you've got your base, which is your number that is being repeated. It's your factors over here. And then the 3 is the exponent, and that's how many times you repeat your factor or your base. Okay, and then remember some of there's two many ways to read a power: 7 to the 3rd power, 7 to the power of 3, or 7 cubed. Remember that cubed is a thing because we're talking about the volume of a cube a cube would have all side lengths of 7. So to find the volume would be 7 times 7 times 7, which is 7 cubed. And same thing with 7 squared, except for we're talking about area. The side lengths of a square would be 2 7s. The area would equal 7 times 7, which is 7 squared. So it's more correct to use 7 squared and 7 cubed rather than 7 to the 3rd power or 7 to the 2nd power. Anything after that we don't have a shape for, so you can just say the number. Moving on, this is a very, very important thing to remember, and it's something that really can sneak up on you. Values with multiple symbols should have parentheses around them. Parentheses, remember, are grouping symbols, so they're going to be grouping your symbols. So for example, we've got two different things here. They look very, very similar, and they oftentimes get mixed up, but they make a big difference. So if I read this one, I read the group first. So -3, there's your group, to the 4th power. Over here, I read each symbol. So the opposite of 3 to the 4th power. So that means, it says opposite of, that means I need to do 3 to the 4th power so that I can find the opposite. Okay, so it's kind of doing this reversal. And that's quite a big difference. And then if you look at your base, if you really, really think about what a base is, on the last slide, the base is whatever is touching the exponent and nothing else. So whatever is being touched. So for example, the 4 is touching the grouping symbol, so the 4 is acting on the group. Over here, the 4 is touching the 3, so the 4 is only acting on the 3 and not the negative. So let me highlight this. This is your base because of the grouping symbol, and over here, your base is just the 3 because that is the only thing that the exponent is acting on. So you can see how similar they look, but they're very different. So we're going to evaluate each one of these by hand just to see how big the difference can be. So this one will be -3 to the 4th power. So I'm going to repeat whatever my base is. So I'm going to repeat -3 4 times. And then I can evaluate. So let's just go left to right like we would if we were just learning order of operations. -3 times -3, +9, carry everything down, times -3 times -3. 9 times -3, -27 times -3, negative times negative, so this will be +81. Okay, so now over here, we want the opposite of 3 to the 4th power. So now that means we need to do 3 to the 4th power. This base, that's your base there. So we need to repeat the base. 3, so we want the opposite of 3 times 3 times 3 times 3. Okay? Well, the opposite of, so we want the opposite of 3 times 3 times 3 times 3 is 81. I want the opposite of that, so my answer is negative, I wrote that backwards, negative 81. So it's a huge difference between a positive 81 and a negative 81. And if I was kind of showing my work over here, instead of writing the words opposite of, I might have wrote the opposite of 3 times 3 times 3 times 3. So just one negative, because I only need one to show opposite. Over here, I had to repeat the negative because it was part of the base. Okay, that will throw a wrench in things as we move along, because we'll be doing lots of things with negative numbers. So you have to be conscious when you're, we're going to do later on when we're substituting, what number are we substituting and how are we going to deal with it when we have exponents. So that's what we'll do at the end of the class. But first, just a few review problems on writing and evaluating exponents. So write using exponents. That means I don't have to evaluate it. I just want to have an exponent in it. So what is being repeated? 3/4 is being repeated. And if you put 3 to the 3rd power, or if you put 3/4 to the 3rd power like that, you are wrong. That would be telling me that the base is only, the 3 is touching the 3. So therefore, that would be incorrect. We need to put this whole thing in parentheses so that we're well aware that all of the symbols have been repeated. Okay, it's really easy to write 3/4 to the 3rd power and not think about it. But then, if someone else looks at it, they won't even know what. They'll think that the 3 is only to the 3rd power. So don't do that. This is bad. Okay, that would be 3 times 3 times 3 over 4. Not what we have over in our example. So the grouping symbols, grouping everything. Evaluate 2/3. Now again, you can read this. 2/3 to the 3rd power. That's how you'd read that. Everything in the base here will be repeated 3 times. So 2/3 times 2/3 times 2/3. And then you can multiply them together. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. And you've got a result. So we've evaluated it. Alright. Write each expression using exponents. Remember, it's all multiplication, so commutative and associative property can be used here. So in my head, I'm looking at this one and thinking about 2 separate things being multiplied together, and those things will have exponents. They can be written with exponents. So I'm repeating the 2/3. So again, since 2/3 is being repeated, make sure you put it in parentheses times 7 squared. So there's 3 of them, there's 2 of them. So okay, and then down here you have the same thing. Make sure you use parentheses for the negative. You don't have to use it for the 3, but you do for the -5 since you would like to see 3 negatives. If I want 3 negatives, I have to put that negative in the parentheses times 3 squared. I could have written it with both parentheses. Well, I probably wouldn't write it this way just because it gets a little too close up in here. So I probably wouldn't write it that way, but I suppose it wouldn't be wrong. I'd like to separate it a little more, just for organizational sake. Alright, so substitution is where you're going to be fine when you have these little easy problems like this. It's substitution that starts to get when you're applying it to a whole bunch of other things. So that's where you're going to run into problems. So make sure that you are careful of your parentheses. So I'm going to do a couple of examples and then you're going to try a couple of examples. So evaluate each expression if A equals -3 and B equals -2. So when I'm looking at these, it's not just substitution you've been doing forever. It's easy. Slow down though, because this is not as easy. A lot of people will want to write, okay, A is -3 squared plus B is -2 squared, but that is incorrect because I need to have the parentheses around each number. Okay, so sometimes what I do is this is kind of how I think about it in my head. I think about it as, okay, it's something squared plus something cubed. Okay, an A goes in here and a B goes here. So it's kind of like fill in the blank then, and then I don't miss something. And even if they had positive numbers, I would do that just so I didn't miss anything. And now you can evaluate. This is -3 times -3, which is +9. -2 times -2 times -2 is -8. So 9 plus -8 is 1. Okay, over here you've got kind of a group squared. So being really careful to pay attention to how many negatives you have. You're going to have 1 on your A, 1 on your B, but you also have a subtraction sign. So that's a total of 3 different negative or subtraction signs, whatever you want to say. So it's always good to be aware of how many you expect to see, because some people will just go, okay, -3 minus 2 squared, because they see the minus and the 2, so like, yeah, that's exactly what B is. But that's not the case. We still have the subtraction sign in there. So it should be -3, because that was A, take away -2, which is B, all squared. And now you can see that you've got a connected dots problem, and you need to evaluate your group before your exponent. So -3 plus 2 is -1, so I'm keeping my parentheses because it's a negative number. -1 squared is -1 times -1, which is +1. Okay, so not difficult, but lots of room for those small errors, especially when you turn into a little bit of a robot and you've done a few. I would like you to pause the video and evaluate the 3 U-tries at the bottom, and then I will go over them on the next slide. So pause the video now and do the 3 U-try problems. Alright, so now I'm going to go through the U-try problems. We had A equaling -4, and, oops, gosh, I'm backwards this morning, and D equaling 9. Alright, so the first one was C to the 3rd power plus D squared. Okay, so again, I use kind of the fill in the blank idea in my head. It's going to be C squared plus D squared, and C, oh, why did I write A and B? A and D. Well, let me fix that. That is C. Hopefully I got this right now. See, I don't have you guys here to make sure I'm doing this right. C equals -4 and D equals 9. Okay, so now I can fill this in. Okay, so C squared, which is -4, the whole thing squared, and D, which is 9 squared, and I'm still using my parentheses because it doesn't matter to have them around the 9. -4 squared is -4 times -4, which is +16, plus 9 times 9, which is 81, so you get 97. Alright, the second one, C plus D to the 3rd power. So substitute in here, we've got -4 plus D, which is 9, to the 3rd power. And make sure you're thinking this is actually subtraction and it's going to be +5 to the 3rd power. I did not use parentheses there because it's positive, but I could if I just wanted to do it on everything, so I didn't miss one. 5 to the third power, 125. All right, last one is d to the third power minus c squared minus 2. Okay, so making sure you're thinking about these variables as fill in the blanks. So d to the third power minus c to the second power minus 2. So there's a whole bunch of grouping symbols in there now. So d, which was 9, and c, which is -4. Alright, so I need to think about order of operations here. I got to do my group. In my group, I've got to do my power. So, and I could do this power outside here. 9 to the third power, which is, let's see, well, it's 81 times 9. 9 times 1 is 9. 9 times 8 is 72. So 729. Oh yeah. 729 minus my group here. -4 squared. So -4 times -4 is positive 16 minus 2. And now I can finish my group here. 729 take away, this is positive 14. And then 729 take away 14 will be 715, right? Yeah, 15. And you are done. One more thing I want to just mention now that we're talking about substitution is, let me give myself a little space up here. So if I had a problem like kind of reversed, where I had d take away c, and like d squared take away c, or something like that, make sure when you substitute you've got 9 squared take away -4. Okay, so that'd be 81 plus 4. That'd be 85. So watch out for those double negatives. Okay, so go ahead and get to work, and remember to watch out for those little wrenches. It can be tricky.